Hey, I'm Ryan from ngrok, and this is my colleague Sam, also from ngrok. And this is the third catch-up that we're having to talk about how he's going with his journey and his adventures running Kubernetes in the browser. So, mate, last time we spoke, you described yourself being in kubelet hell. You'd gone from 20,000 lines of code, roughly from episode 1. And then the second time I spoke, you were between 40 and 50,000 lines of code. It's been a couple of weeks. So, yeah, mate, where are things at?
Something like 80 to 90,000 lines of code now, I think. Not quite exponential, I guess, because there's been a bigger gap than usual between the last two episodes that we have here. But it is a lot. So it's way more than I was originally anticipating. I think I spoke in the first episode where I did this completely vibe-coded, make something Kubernetes-esque that ended up being like 5,000 lines of code, and that gave me this false sense of, hey, how hard could this really be? So it's I think as well as I go along and I see it working, I have at several points gotten to the point where I can connect certain things up and build visualizations in the browser with it, and seeing it working, I think, has spurred on the ambitions a little bit. So I'm currently implementing a bunch of controllers. So in Kubernetes, controllers, what they do is they monitor certain resources and they make sure the state of the cluster is up to date with the state of those resources. So a good example is replica sets. So a replica set says, here is a pod template and I want 3 copies of this pod template running in the cluster. And the replica set controller will dutifully go and spin up those pods. It just kind of creates pod resources and the kubelet spins the pods up, but it makes sure that if, for example, one of those pod resources gets deleted, it will bring up another one. So its job is to make sure it's always 3 versions of this pod. And then deployments will create a replica set under the hood, and they will manage like updating to a new image, for example. They manage the process of doing that update in a way that's like zero downtime. So they will only ever be swapping out like 20% of the pods at a time, for example, and they'll monitor the health of the pod to make sure the rollout's going smoothly. So they encompass a lot of that logic. And I wanted to have these in place for the first post that I plan to write with this library, which is about probing, because I want to show the impact that probing configurations can have on deployment times and things like that. So I wanted to have a good deployment and replica set controller ready for that. But it turns out they're real complex. There's a lot going on. It also means I've had to interface with whole swathes of code that have nothing to do with the kubelet. So I spent a lot of time in kubelet hell bringing lots of kubelet related utilities across. And then these are the first proper controllers that I'm writing. And they have their own sets of utilities that are completely separate from the kubelet and stuff like that. So there's just been a whole bunch of new stuff that's had to come across. And it's been made easier with AI and LLMs. But I still am in this mindset where I am reviewing every line of code that goes in and making sure that it does actually do what it's supposed to be doing compared to the actual Kubernetes like upstream code. So yeah, it's accelerated a bit. I think I'm like able to make faster progress now that there's quite an established code base to build upon. But I will say I'm getting real close. I am hoping to have like a public repo with this code in, with a demo application showing off using this library this week. That's the plan. So we're recording this on Wednesday, the 17th of June, in the morning, my time. And I anticipate by the end of the week, we'll have that repository out there so people can then go and actually like have a look at the demo app and have a look at the code and have a look at the interfaces and if they want to like start building on it. Like what I will say, if you are listening to this thinking, ooh, I'll go and like try building something with it. It's early days. Nothing has actually like meaningfully been built with it yet. The demo application is the closest thing. So I have this demo application that shows a full cluster visualization with traffic moving between pods and things like that. So there is something built on top of it. And I've had a bit of an opportunity there to smooth out some of the APIs so that the things I need to be possible for the posts I have in mind are actually possible. I do anticipate like as time goes on, some of those interfaces might shift a bit. So if you do plan on building something early, and I will put this in the README, it is like alpha level software, it's going to change a bunch. Please don't be mad at me when the interfaces that you've built on top of change. Like, this is still very shifting.
So I'm sure a lot of people are going to have questions about how did you implement a container runtime, or how did you do networking? Do you want to talk about some of the parts of your implementation where you had to mock things and how you went about it, and has your approach to that changed, when you started out and then, to where you are now, some 90,000 lines of code later?
Yeah, I anticipate this being the biggest hurdle, because the catchphrase like Kubernetes in the browser, it's really nice and pithy. It doesn't tell the full story. Like, yes, it's Kubernetes in the browser, like asterisk. Like, you can't run real containers. There isn't like real networking necessarily going on. And this is because I didn't need those things, right? This is meant to be a tool for teaching people. So I don't really want to be like pulling real containers. It's meant to be quite light over the wire, so it just loads in a web page without having to have like loading spinners or anything like that. I don't want people to be pulling in real like 50 megabyte containers just to use this thing. So the containers, there is an API that you have to interact with, where you will define a class which defines a function called exec, and that is kind of your container. And then the exec function gets passed a set of arguments, which comes from like the pod manifest. Like, if you set the command in the pod manifest to like ls some directory, then that will get passed into this exec function in the image that you define. So it's a little bit of like almost like a, not quite domain specific language, but like it's a little interface in TypeScript that you would have to interact with to define your own workloads. So if you were wanting to write some piece of content, or maybe even make like a whole course on something, you would be defining your own images that exhibit the behavior that you want to show off in the course. So an example of this is in the demo app that I am building. Something I am allowing you to do is toggle for every single pod how it responds to health checks. So you can say respond with an error to your readiness check for each individual pod. And that's all working using the Kubernetes like machinery that I have built. So it will use the cluster network under the hood to talk to that pod, and that image has registered a port for, and that port will accept certain HTTP paths. So you're sending it literally a HTTP API call to say respond to readiness checks with an error. And it saves that state in its own little virtual file system, and then the health checks will check the file system to see how it should respond to the readiness. So it's not like there's no like smoke or mirrors necessarily. Like, I am using the Kubernetes tooling to do that stuff, right? Like, it's all using stuff that you could do with a real cluster. In a real cluster, you could define a container that does the exact same stuff, and there are containers out there that do that. Like, I am using those in my parity tests, for example. So all this to say, not real containers, so don't get too excited about like running any old OCI compatible container in the browser. It is a custom like TypeScript API, and the reason behind that is to meet my kind of like educational goals, where this should be something that can just be downloaded on the page, not very heavy over the wire. And then the container runtime, it ends up being this like an image registry. So you register the images with a specific name, and then that is what gets referenced when the image pulling code. So Kubernetes has a bunch of code for image pulling in the kubelet, and the kubelet talks to an image service, which I have essentially defined my own image service that knows about the images you have defined, and it will give the container runtime an image, and the container runtime knows what to do with that image, because that image is the API that I have written. So it knows from this image it can spawn a new process and then call the exec function. So I have my own like container runtime service running as well. So from the kubelet's perspective, it's doing all the same things that the actual real kubelet does, but it's talking to something that works very, very differently to something that would run normal kind of OCI containers like Docker or Containerd or something like that. And then networking is a bit more of a bodge. It works the same way that Kubernetes does, in that there is this pod in Kubernetes called kube-proxy, and its job is to maintain networking configuration on each node such that pod IP addresses can be routed between nodes, right? So it's possible when a new pod comes online, it's like that pod has this specific IP address. The kube-proxy goes and makes sure like IP tables rules are up to date to make sure that that can be routed in the cluster. That's one way of doing it. There's loads of different ways of doing container networking, and that's just kind of one of them. What I have instead is this class called cluster network. And the cluster network is something that my kube-proxy has a reference to. And for new pods, it literally just tells the cluster network there is a pod with this IP address now. And then the cluster network is what I route fetch requests to. So fetch, I'm using the browser fetch API. So this cluster network has a fetch function that looks just like the fetch from the browser that actually kind of routes IP addresses, excuse me, that it knows about. And it routes DNS names it knows about as well. Like I have a kind of fake core DNS image that runs in the cluster that will watch for new pods and new services, and it will make sure that name resolution for those services will map to the pods in the cluster. So this cluster network, the first thing it does if it gets something that isn't an IP address is it goes and asks the core DNS pod, what is the IP address for this name, just like it would in real life. And then core DNS, if it knows about it, it gives those IP addresses back. And it all sort of like mimics real life in a kind of like way that behind the scenes it's all kind of botched. and it does what it needs to, it works, but there's no kind of like real networking or real DNS going on. It's all kind of fake so that it works in this browser environment.
Fun things that could be potentially extended, once this project is done. I have the feeling that it will never be done. But, if it might be hard to say, but if you're looking down the track, 3 to 6 months, what are some things that you'd really love to tackle to take this to the next level? Yeah,
that's a very, very good question. And it touches on this idea of, and I intend to address this in the README, but this is not like all of Kubernetes, right? This is not a full implementation of all the possible resources that you could do. It is just a slice of things that I'm needing for the stuff that I'm working on at the moment, which is probably going to be limiting for other people. Like if so, for example, people want to do a post on like network policy. I haven't implemented network policy controllers or anything like that. So they would have to do that legwork if that's something they really wanted to do. And if they wanted to do the legwork, like I am happy to work with people that want to extend this. Just email me or reach out on social media and I'll see what I can do to help. And also like keeping up to date with new Kubernetes versions. Like right now I'm targeting 1.36 because that's the current latest version. I'm kind of intending as new versions come out, I will update my tests to run against the newest version to make sure that I'm at parity with the newest version, but I won't be obviously supporting like all of the new features in every new version because that's just unrealistic. So that disclaimer out of the way, what do I want to work on the next 3 to 6 months? So network policies are actually really interesting to me. I think network policies would be somewhat easy-ish to implement. And I say easy with a bit of an asterisk there. I can see a route to do it, but it's going to be a bunch of work to actually get it in. There's some more obvious things. So for example, I've not done anything to do with init containers. So init containers will run before the main containers in your pod, and they just initialize kind of some state that you might need. Those would be relatively simple to get in, I think. And then another thing I have not really modeled is storage. So volume claims and things like that. So that you can have like persistent volume storage. And again, I see a route to doing that as well. So that should be possible. And then that's also going to feed into things like config maps and secrets, mounting those into like environment variables. None of that is in place today, but config maps, I think, would be something that a lot of use cases would need. And I don't think they would be really, really, really hard to support. So they would be a nice thing to get in. So yeah, mostly expanding on the set of primitives that are available to people. And it's stuff that like almost every workload out there in the real world, like in production, is using config maps, is using secrets, right? Those are table stakes stuff. So I'd like to complete the set of those things that like the majority of people will bump into.
Now that we have LLMs to help us, take on incredibly ambitious projects, when you were talking about the container runtime before, and there's the class and there's exec. How far could someone emulate something close to a real image? Like you're porting Kubernetes to run in the browser. That's tens of thousands of lines of code. What's to say that someone couldn't build something like a container runtime with the same sort of idea, even if a primitive, not fully functional one?
The thing is, so I learned recently. So Annie Sexton and somebody else on our content team taught me about Atwood's law, or like the Atwood principle, or something like that, where it's basically Jeff Atwood saying that anything that can be written in JavaScript will eventually be written in JavaScript. And she said this is a good example of Atwood's law, and I agree. The thing is, browsers, people have already gotten Linux running in the browser, right? They have gotten x86 emulators running in the browser. And once you have that, you can then just run the real Kubernetes binaries. But there's downsides to that, right? Like the real Kubernetes binaries are pretty big. Like real Linux is pretty big. Downloading and running the Linux kernel is probably tens of megabytes. He says, not actually having looked this up, I'm kind of just assuming, but I know real Kubernetes binaries are probably tens of megabytes as well. And then you are emulating an instruction set that's not native to the browser, so that's going to have overheads. Then you need to pull real images. The problem with this approach, while it's doable, I am assuming, it's not practical. So it's probably going to be quite slow. It's probably going to be quite heavy over the wire. I needed something that the page should just load. There shouldn't be any funny business going on. It should be something that just loads. And at the present time, it's clocking in between 250 and 300 kilobytes. So it's like a medium-sized image in terms of how big it is, which I'm happy with. I think that's acceptable for the functionality that it grants me. If it was several megabytes, it starts to become impractical, especially for people in parts of the world that don't have reliable or high throughput internet connections. That's not good for what I want to do here. I want to help educate people in Kubernetes, and I want to educate all of the people if I can. I don't want people to be locked behind, tens, maybe even hundreds of megabytes of downloads. So a good example of excuse me, a really great website that does actually need enormous amounts of bandwidth in terms of you need to download lots of stuff, is there is a great website called I think it's called Transformers Explained or Transformers Visualized or something like that, and it's this wonderful visualization of the GPT-2 model. So GPT-2 is about, I think, 600 megabytes. Don't quote me, but it is hundreds of megabytes for sure. Excuse me. And while that's downloading, they give you some pre-canned sentences. They've obviously pre-calculated what all the stuff should be, all the internal visualizations of the network should be, with some canned sentences. And then when the actual full thing downloads, you can then go wild and put any text you want in as a prompt, and then it will show you generating tokens and all the internals of the network. And that's an incredible website and an incredible usage of what's the word? Almost progressive enhancement, I guess, where you while you're waiting, you have something to look at. I wanted to avoid that where possible. I understand why they did that with this website. It's just that's the realistic way to do it. But with this Kubernetes thing, I think for a lot of use cases that there's not going to be an easy way to give something to look at while things are downloading. So how far could you take it? You could actually emulate the real Kubernetes. I have no doubt that's probably possible with somebody who had enough time and inclination and maybe the lack of inhibitions, I guess. Or if you really wanted to do it, I'm sure you could do it. It wasn't going to meet the goals that I had.
Yeah, that's what I was going to ask is, when you were starting this project, I imagine you looked at all of the possibilities. So what were some of the options that you looked at for running Kubernetes in the browser that wasn't rebuilding it in TypeScript? And why didn't you go down those paths?
I definitely didn't enumerate all the possibilities. I knew that some of them just were impractical. Like actually running actual Kubernetes, it's impractical. I'm almost certain. The main things I entertained were, because this came from wanting to write a blog post about probing, and I had this dream of like, I would love it if people could input their own probing configurations and then have this sandbox they can play in to see what different like changing different parts of their probing configuration, how would it actually change how their workloads operate in production and simulate certain like disaster scenarios, like nodes disappearing or like pods becoming unhealthy and things like that. And the road I could have gone down there is reading and understanding the Kubernetes code surrounding it and trying my best to create the most stripped out simulation of it. So rather than building a kubelet or anything like that, just build this probing simulator that somewhat exhibits the same behavior as real Kubernetes. And the way I could have tested it is I could have set these scenarios up in an actual Kubernetes cluster, recorded what happened, and then made sure the stuff that I'm doing in the browser matches that behavior. That was a road I could have gone down and was considering going down. The reason I didn't go down that road is it's just a lot less cool. It's a lot less cool, and it's a lot harder to be really confident that the accuracy of the simulations is correct. Like, yes, I could, for any combination of things that I think of, I could test it against a real cluster, and I could have built tooling to validate that things that should be happening are happening. But then, like, if the user wanted to put a different combination of things in, they could hit edge cases where my simulation is not considered like the way that the Kubernetes cluster actually works. Now, my approach I have gone down, like to kind of port over big swathes of Kubernetes into the browser, could actually have the same problem, right? Like, there's no guaranteeing that I have done this fully correctly. There's no guaranteeing that the JavaScript runtimes in the browser just work fundamentally differently to Go. Like, Go has Go routines, which run on a pool of threads, and the browser is single-threaded, and these things are going to come out slightly differently. So there's every possibility that things work differently in my browser-based version to the actual Kubernetes real version. But I feel better about it because I know I have put the effort in to try and make sure that the code I have written in JavaScript here is doing what the actual real Kubernetes code does. Like, I've gone line by line for like tens of thousands of lines and made sure that as much as possible I am as close to what is happening upstream as it can be. And there's over 2,000 tests now as well. Lots of those ported from the upstream Kubernetes project to make sure that what I have done is behaving the way that the upstream project does. But despite all that, it could be slightly differently. So, there will have to be some level of like, if you really, really, really need accurate simulations of your probing configuration, you are going to have to do them in a real cluster in production as well. But hopefully the level of accuracy I can offer with this browser-based version is indicative and gives you a good idea of what you should try in actual production. That's the idea. So yeah, didn't enumerate every single potential possibility. I just had this sense that some of them were going to be impractical or even impossible. This one felt like it was a maybe not reasonable balance, but a doable balance between trying to hit the highest level of realism that I could and trying to make content that is like as cool as possible. Like, it's cool to just be able to like kill off a pod and see what happens, or resize a deployment and see what happens, or fail a readiness check and see what happens. That's difficult to achieve in anything less than a kind of port of the actual code,
So in terms of demoing what you have right now, what is the current visualization that you've got?
I have a 3-node cluster in a web page that has 12 pods running within it. Those 12 pods are split between 4 different deployments. So 4 deployments of 3 pods. There is a traffic generation pod. There is an API pod. There is a database pod. And there is a Redis pod, I think. The traffic generator sends requests to the API pods. The API pods then send one request each to a database and to Redis, and then that all returns back to the traffic generation pod. And the idea is to show a somewhat normal-ish request flow that you'd see in any kind of web backend piece of software. And every time a pod sends a request to another pod, you see a little dot move between the pods that is requesting and being requested. And it's kind of nice to see like the traffic generator sends the API then fans out to two other pods and they come back and it all goes back and it's all very lovely. And then underneath this 3 nodes kind of side by side, there's a table that shows you all the resources. So it's a tabbed kind of table and it has pods, services, deployments, replica sets that you can tab between. Some of them have actions you can do. So on deployments, you can like increase or decrease the number of replicas in your deployment. In the pods, you can delete a pod and then you can see the pod gets replaced. You can set the readiness and the liveness for pods. And if you set the liveness to fail, then the pod will eventually get restarted. And if you set the readiness to fail, that pod will eventually be marked as not ready and it'll stop receiving requests. You can kind of hover over each of the rows in these tables. And like if you hover over a pod, it'll highlight which pod it is in the cluster. And then if you highlight a service, it will highlight all of the pods that are part of that service. And then for everything in the table as well, you have this ability to like inspect the manifest to see the actual YAML of the pod resource or the service resource or whatever. So it's kind of meant to be a bit of a kind of holistic visualization of what's happening in this kind of fake cluster that I have running in a browser.
Yeah, it sounds cool. Like someone they're not just looking at the visualizations on a page, they can really get in and explore a cluster. It sounds great. So you're what did you say, about 90,000 lines of code in at this point?
Yeah, there or thereabouts.
Looking back now, because you started this project many weeks ago, have there been any interesting decisions that you made way back when that are having interesting consequences for you now, or might have interesting consequences for you in the future?
There are definitely earlier mistakes that I am paying for. I say early mistakes. I think I actually spoke back in episode 1 about the decision to use, for example, the JavaScript Node SDK API surface to communicate with the cluster. So JavaScript, there's a Kubernetes project called Kubernetes/node-client, and this is just the JavaScript API for talking to Kubernetes API service. And it's the thing that, like, when you run like kubectl pods or whatever to list pods, kubectl is sending an HTTP request to the Kubernetes API server to request a list of pods. This library I'm talking about here is just the JavaScript client library to do that. It's been very handy. It means I have an actual like type surface to emulate, and TypeScript can enforce that type surface is being maintained. And it's also anyone who is then used to or has used the Kubernetes JavaScript node client library for Kubernetes will be familiar with it, and it will work pretty much the way they are used to. But while that is like the external API service, the problem I have is that in my cluster, anytime I want to talk to the API server from within a controller or from within the kubelet, I have opted to use that same API surface. This isn't what the Kubernetes project proper actually does. It communicates with the actual like HTTP request surface. So there is an internal client library inside Kubernetes that can talk to the API server over the HTTP API. It looks different to the client libraries in a couple of interesting and painful ways. I won't enumerate them, but basically it's different. And it means that when I am trying to write, say, the replica set controller, the replica set controller in Kubernetes is actually making a bunch of like HTTP calls and stuff like that using an API surface I don't have access to because I have opted to use my Kubernetes/client node API surface. So it means I have to do things differently in some places. And it's just extra kind of cognitive effort to make sure like I understand what's happening in the upstream code, and I understand that what I have done here is a reasonable imitation of that. Whereas it's much easier to just kind of go line by line and see, yes, these lines are exactly the same, and I've got exactly the same abstractions. Here I have to actually think a lot harder about, like, okay, this is doing the same thing and has similar edge cases, which is hard, right? Like, if there's going to be deviations in behavior between the two projects, it's going to be in places like this, right? Like, it's very difficult to say that I have done the exact same thing and I've copied the exact same behaviors for these two very, very different API services. I say very different. They're fairly different. They're not like super duper different, but they're annoyingly different. So yeah, that's been painful. Similarly, like, all the controllers in the Kubernetes project have this concept of an informer. And an informer, its entire job is you give it a resource that you care about, like pods, for example, and you start the informer and you give it callbacks. So you say the informer should tell me when a pod is added, deleted, updated, and you give it functions that get called when these things happen. And the first thing the informer does is it sends you add events for all the existing resources, and then it watches for changes, right? So the idea is it gives you this interface where you know for a fact you are going to get knowledge of all of the objects of that resource type, and then you will get updates on an ongoing basis. The informer interface that the JavaScript Kubernetes client library exposes has real annoying differences to the informer interface that the Kubernetes project has internally. The big one is internally in Kubernetes, on an update call, you get the old object and you get the new object. In the informer interface that's exposed by the JavaScript client library, you just get the new object. And I cannot change that without breaking the type compatibility of that API. And I don't want to do that. So I have had to make like annoying little shims around this informer interface that gives me the old object on updates. So there's just like little things like that that are just getting in the way. I think eventually I would like to have an HTTP API that mimics the real one, and then move things to that, because it's going to be cleaner in the long run because it's what's actually happening upstream. And it would also mean that this could potentially be run in Node.js, and you could actually potentially point kubectl at this instead of a real Kubernetes cluster and control it with kubectl, which would just be good fun. So yeah, definitely some early mistakes that are costing me, but nothing catastrophic, I don't think.
Yeah, I can imagine a common feature request would be an inline shell in the browser, being able to run kube control commands or kubectl commands. Lots of cool stuff to do and to implement in the future. So, all right. So the plan is in a few days, you might have the repository open sourced. So what are the remaining things on your list before you can do that?
Getting these controllers for replica sets and deployments. They currently work, right? But I haven't fully reviewed them to make sure they work exactly the same as the upstream code. So that's just a time-consuming and laborious process that has to happen. Otherwise, it's just slop, and I don't want to release slop. Once those are in, the final remaining thing, honestly, is to write a really good README. There is like a pretty basic README at the moment, but I want to make sure that the goals of the project are very clear. The state of the project, like it's kind of like an alpha project. I want that to be very clear, so people building on it don't get a false idea of how stable it is. And I want to make sure there's good examples. Like the demo app is a nice, like holistic example, but it is in itself a reasonably large amount of code, so it would be difficult to look at it as like an API reference or anything like that. So an actual API reference would be quite nice. An example of like, here's how you make some images. Here's how you run those images in the cluster, just to give people a sense of how this thing works. I think like a full API reference will be punted until after release, but I would like to eventually have one. Publishing it onto NPM is on the cards as well. That has to probably happen. I think that can happen after the open sourcing. But yeah, those are the things on my mind. The main thing, get these controllers in and working correctly. I need to deploy the demo app somewhere, so I can give a link to it. People can click it and see it. Like it's all well and good. They can clone the repo and run the command, but like people don't want to do that, right? People are on their phones. They want to tap a link and play with it. So getting that done is on the list, but that shouldn't be too challenging. So yeah, just a few things to clean up here and there. I'm hoping. I'd really like to have the controllers committed to master by the end of today. That would be nice. But there is a possibility that will leak into tomorrow, depending on how difficult that review is. So yeah, probably tomorrow or Friday, I'm thinking to have things pushed up into the public repo.
Well, mate, it's been a long road to get here, and I'm very excited for you that it's coming to fruition and it's all becoming very real. I reckon that's a good place to pause. And yeah, next time we catch up, the repo will be open sourced, and who knows what we'll be talking about. But yeah, mate, really, really pleased for you and excited to see how the community is going to react as well.
Yeah, when this has been open sourced, I am taking a week off because I have not taken time off for a little while, and a little reset before I start the next project, which is going to be writing the blog post on probing. So hopefully when we're back to the next one of these, we can talk about whether or not people have like picked this up and tried to do stuff with it, and then like how the progress is going on this probing blog post.
Yeah, brilliant, mate. All right, well, until then.
Amazing. Have a good one.
You too, mate.